Hello everyone, I'm glad to talk about our work, Lattice Menu today. My name is Taejun Kim, and this work was done at SIGCHI lab with my great collaborators Auejin, Sunggeun, and my advisor Geehyuk Lee. Eye gaze input has a potential to free users from physical constraints, and a well-designed technique can provide natural and subtle hands-free interaction. Nowadays, hands-free system control with a gaze-controlled menu became more viable as major AR and VR headsets have their own built-in eye trackers. In this background, we revisited the marking menu concept. A marking menu is a radial menu that allows users to make a selection by drawing a mark to the desired item, which offers fast selection skills for expert users. Once users remember the location of their desired item, they don't need to navigate the hierarchical menu step by step. And gradual transition from novice to expert is naturally supported as the novice user's menu selection becomes a rehearsal of expert gesture skills. So, we transfer these benefits of a marking menu into a gaze input domain, which means a gaze-based marking menu. However, unlike the hand, the ballistic nature of the human eye movement makes it challenging to design a safe gaze-based marking menu. So in previous studies, researchers have employed visual targets to anchor the gaze for providing stable interface control. So inspired by previous gaze-based interfaces, we thought of integrating visual anchors into the marking menu for stable menu selection. So here, we present Lattice Menu, which is a gaze-based marking menu with a lattice of visual anchors. Users can select a menu item by looking at the corresponding visual anchor outside the border of the pie slice. When a user knows the required trajectory to the desired item, target-assisted gaze gestures can be performed. In this study, we implemented and evaluated the Lattice Menu technique in a VR environment under a 3-level hierarchical menu structure. From here, I will describe the user studies of the published paper. First, we explore several dimensions to optimize and finalize our Lattice Menu technique. Then, we evaluate the performance of the designed Lattice Menu across different menu layouts. Finally, we compare the performance of Lattice Menu with traditional gaze-based marking menu that does not utilize visual anchors. So first, visual distraction owing to the lattice of visual anchors on the screen is a critical usability problem. And as a solution, we devised the progressive Lattice Menu. And it progressively unfolds the visual anchors that are directly used for the current menu level's item selection. In the first preliminary study, we examined whether the user performance of target-assisted gaze gesture can be still retained in progressive Lattice Menu. So for the result, many subjects preferred progressive Lattice Menu because of the discomfort of visual distraction experienced in the full Lattice Menu. And as it will be more crucial in a realistic environment with dynamic visual contents, we decided to pick the progressive Lattice Menu. Next, in the second preliminary study, we explored the saliency of visual anchors that can help a rapid and accurate eye movement. We compared 3 different types of visual anchors: white point, red point, and a cross point. For the result, the performance of each visual target were not significantly different. However, most subjects shared bad experiences on over-saliency of red point and cross point condition. They said they felt higher eye fatigue on that conditions, so we picked white point as the best visual target. And this is our Lattice Menu technique optimized through preliminary studies. Progressive Lattice Menu with white point target. In User Study 1, we evaluated the performance of the designed Lattice Menu on various menu layouts. For overall performance, Lattice Menu showed considerably low error rate and short menu selection time for expert usage. In User Study 2, we compared the performance of the Lattice Menu with the traditional technique that does not utilize visual targets. In the result, remarkably less menu selection errors were shown in Lattice Menu, about 5 times lower error rates in average. This is a scatter plot of saccade landing position for both Lattice Menu and the competitor. We can observe that the lattice of visual anchors help users to better follow the shortest gesture passes for selection. The visual anchors facilitate stable menu selections with reduced eye fatigue. This is the end of my presentation, and I would like to thank to my awesome co-authors of Lattice Menu. And if you have any comments or questions on our project, please contact the authors. Thank you for listening.